Kamiak Butte is an integral aspect that influences the rich ecosystem found in the Palouse. This report will cover the geology, evolution, climate, topography, biome, and anthropogenic changes, all centered around Kamiak Butte. Kamiak Butte is located in Pullman, Washington, in the rolling hills of the Palouse. Kamiak Butte is a very interesting geologic feature among the landscape as it sits high above the rolling lusk-covered hills on quartzite bedrock. Kamiak Butte has a unique geology, biome, climate, and landscape that all plays a role in its rich diversity. Here, plate tectonics form mountains, volcanoes, and can create earthquakes from their movement and interactions with each other. There are three types of plate tectonic boundaries: convergent boundaries, where two plates move towards each other; divergent boundaries, where two plates move away from each other; and transform boundaries, where plates slide up next to each other. Kamiak Butte is a unique feature because it was created through accretionary wedges that scraped off the Juan de Fuca plate as the North American plate moved further towards the Pacific Ocean. The positioning of Kamiak Butte was not always the way it is now. A theory suggested by Alfred Wegener was the idea of continental drift. He believed that there was once a supercontinent, but due to the movement of plates, it drifted apart. The Pacific Northwest has had a very vibrant evolution and is still currently going through slow changes every day. Washington State is located on the Cascadia subduction zone, where the Juan de Fuca plate is subducting under the North American plate, resulting in volcanoes, accretionary wedges, and earthquakes. The Olympic Peninsula, and in earlier times Kamiak Butte, are accretionary wedges created by subduction. As the Juan de Fuca plate subducts under the North American plate, the materials from the plate are scraped off, creating a landmass. The material that is scraped off contains sand, silt, chunks of basalt, organic matter, glacial till and erratics, and volcanic ash. Kamiak Butte is located on the Columbia River basalts. It is the world's youngest flood basalts that formed between 17 to 4 million years ago during the Miocene epoch and reaches from Idaho into Washington, Oregon, Nevada, and California. The basalts once covered around 63,000 square miles. The basalt layers were miles thick and carry so much weight that they have created a low spot in the landscape. The basalt layers form from massive eruptions from rapidly migrating vents from the Yellowstone hotspot between the accreted terrains and the North American Craton. The vents are now located over Yellowstone. Kamiak Butte, however, is made up of quartzite material, not basalt, because the butte used to be tall and large, and when the basalts were erupting, they were not quite thick enough to cover Kamiak Butte entirely. The last ice age played a huge role in the type of landscape and soil found on and around Kamiak Butte. The last ice age covered much of the world in a thick, dense glacier that stretched as far as the Cascades in Washington and the northern tips of Idaho and Montana. The ice age ended around 11,000 years ago. The Bonneville and Missoula ice floods shaped the landscape of eastern Washington and helped create the rolling Palouse Hills surrounded by Kamiak Butte. Towards the end of the ice age, more precipitation fell that filled the rivers and lakes around the thick glacial wall near the Clark Fork River in western Montana. It blocked the flow of the river's water to Idaho and Washington, forming Glacial Lake Missoula that was 300 kilometers wide. When the ice age eventually collapsed, millions of gallons of water rushed out towards the Columbia River basalts, scouring out the land until it reached the Pacific Ocean. The Wallula Gap restricted the water flow, where the floods went from high speeds to almost a complete stop. The Twin Sisters were so narrow that the water struggled to flow through, which created Lake Lewis. When the lake eventually flooded through the Twin Sisters, it brought with it all of the rich sediment as it flowed towards the Pacific Ocean. Because the Wallula Gap trapped so much sediment and debris into Lake Lewis, when the lake finally subsided, all of the sediment was transferred down the Columbia River towards the Pacific Ocean. Marine polar air systems blew the Lake Lewis debris soil back east, making it the perfect size to settle on the eastern Washington landscape. The debris soils are what created some of the most fertile farming soil in the world, loess. The loess that sits on top of the basalt layers found on the Palouse are very fertile for various reasons. When rain falls, it flows through the loess soils until it hits an impermeable layer of basalt, It traps the water nutrients on top of the basalts, leaving less soils nutrient-rich and agriculturally productive. Less soil that sits on top of sedimentary quartzite acts a little different than the basalt layers due to the more permeable ability of quartzite material. Water moves quickly through the material and strips it of nutrients, making it harder to grow barley or wheat. There are 4 types of air masses that influence climate on Earth and are oriented from their source regions: continental, maritime, tropical, and polar. Marine polar air masses tend to be cold and very moist. Cold and moist air blown up from the Pacific Ocean, bringing heavy snow and precipitation to the Palouse region. Macroclimates are broad-scale climates of a large region within a continent. Kamiak Butte is in the maritime modified continental macroclimate, where the climate is influenced by both marine polar and continental polar air masses. It has long, cold winters with a lot of precipitation and hot, dry summers. Topography is often influenced by different parameters. Different topographic features can influence the type of precipitation and vegetation and will determine the specific microclimate of a region. The marine polar air mass coming off the Pacific, combined with the continental polar air masses coming from the Rocky Mountains, creates a unique Palouse climate. Kamiak Butte's climate is also heavily influenced by its topological aspect, the direction the slope is facing. The amount of solar radiation strongly influences aspects of microclimates. The south aspect of Kamiak Butte receives more solar radiation, which increases evaporation of water from its surface, increasing the amount of transpiration by plants, which further promotes convective air movements, making the microenvironment drier. The north aspect receives less solar radiation, allowing for very different plants to be grown to do less evaporative processes. The rain shadow effect is very important for the understanding of Kamiak Butte's climate. A is the point where the air mass begins to cool over land. Point B is the area where precipitation begins due to mountains. Point C is where the air mass reaches the top of the mountains and begins to descend. Point D is the descending air mass warming. E prime to E is where the air mass reaches its lowest and warmest latitude. F is the point that is considered the area of rain shadow effect. Kamiak Butte is located in the rain shadow region of Washington due to the Cascade Mountains, which is why it receives less moisture than the western side of Washington. Kamiak Butte has a very unique climate. It is placed in the Palouse, surrounded by different North American macroclimates, which leads to a relatively cooler but somewhat moist climate. Precipitation levels fall between 20 to 30 inches annually, and temperatures range from 30 to 60 on average annually. The most precipitation on Kamiak Butte is typically found between March through May and September through December. Precipitation on Kamiak Butte do include snowfall because of the average temperatures in the winter that are colder. A biome is a regional area that is comprised of different landscapes and distinctive ecosystems that is influenced by a particular climatic regime. There are 14 different distinctive terrestrial biomes in North America. Climate is the most important abiotic factor affecting the types of growth forms of vegetation in varying terrestrial biomes. Kamiak Butte is located in the North American Western Interior Shrublands and Woodlands biome. It is a very unique and expansive biome that stretches from the Columbia Basin through the Great Basin and down to the Colorado Plateau. The Shrublands and Woodlands biome is located in the marine modified continental macroclimate, which is essential for understanding the dominant types of vegetation found across the biome. Trees found in Kamiak Butte include Douglas fir, western larch, and ponderosa pine, and various bunch grasses and wheatgrasses are also found along both aspects of the butte. The plant communities found in the north aspect consist of lush ferns and bushes and large Douglas fir and western larch trees that reach 80 plus feet. Contrary to the north aspect, the south aspect has fewer trees, mostly ponderosa pines, that are smaller and spaced out. Dry grasses and shrubs dominate the south aspect. For sharing the same butte, the north and south aspects have drastically different forest attributes. The north aspect has a very lush forest with tall trees, numerous shrubs and ferns, and a large canopy cover, whereas the south aspect has a sparse number of trees that are drastically smaller than the north aspect. It has very little canopy coverage with more shrubs like bunch grasses and wheatgrasses coverage on the floor. All of the trees on the north aspect are very tall and thick. The average height for the Douglas fir was 98 feet tall, the average height for the ponderosa pine tree was 110 feet tall, and the average height for the western larch tree was 97 feet tall. Because of the large height of the trees and the thickness of them, there is a large amount of canopy coverage that stretches over the entire aspect. There is an average of 158 trees per acre on the north aspect. The understory of the north aspect is filled with smaller plants and trees that thrive under the canopy shade of the larger trees. The fourth floor is almost completely covered with very little soil exposure. Plants such as mosses and lichens are expansive and cover much of the floor in the north aspect. The north aspect is characteristically very lush and plentiful because the trees had a much slower succession, allowing them to grow larger. As a result of the lush vegetation on the north aspect, there is a greater water storage and more continuous nutrient cycling at larger quantities than what is found on the south aspect due to its thriving vegetation. The south aspect is drastically different than that on the north aspect due to its lack of lush tree coverage and grass cover. The average height of the trees on the south aspect is 40 feet tall, and there are 35 trees per acre on the south aspect. There is very little canopy cover from the trees on the south aspect since the trees are smaller and more sparse. Along with ponderosa pine trees, there are more bunch grasses and wheatgrasses found on the landscape floor. There are no ferns as it is lacking the lush green coverage found on the north aspect due to its low capacity for water storage. The succession of the trees was much faster on the south aspect, which leads to smaller, skinnier trees. Because there is less plant life found on the south aspect, there is a smaller flux of phenology, which leads to less nutrient cycling. The grasses and shrubs on the south aspect allow for deer and other grazers to use it as food, which attracts a lot of wildlife. Carbon sequestration is the process by which trees take up the atmospheric carbon dioxide through photosynthesis and store it as carbon in biomass within the plants. Although it may seem like the amount of carbon sequestration varies on the north and south aspect due to the different sizes of trees and amount of vegetation, the ratio of carbon is very similar on both aspects. However, the difference in vegetation and plant life comes from differences in biomass. Because there is more vegetation on the north aspect of Kamiak Butte, there is more humus available for nitrogen fixation, which allows for more nitrogen to accumulate on the north aspect, allowing the nitrogen to circulate through the vegetation quicker. The more vegetation in plants, the more humus and nitrogen that can be readily available for plants to use. Since the south aspect doesn't have as big of an abundance of plants and trees on the north aspect, nitrogen is less available for the plants because there is less humus, which can also lead to greater leaching, leaving less nitrogen in the soil. Since Kamiak Butte is located on quartzite, a very permeable rock layer, water is able to move through it a lot faster, so having more humus means greater amount of vegetation that will be able to survive. Due to agricultural conversion of the landscape around Kamiak Butte, the native grasses found in the western interior shrublands and woodlands biome is being replaced with non-native grasses, wheat, and other crops. A little more than 1% of the Palouse grasslands remains. Livestock grazing has also stripped the land of the native grass species. Kamiak Butte is home to many species, including the mule deer. Many of those animal species that are facing large-scale reduction of habitat due to land conversion of tilled agriculture and urban development. Conversion of native shrub steppe landscape to agriculture has resulted in a 50% loss of habitat area. Kamiak Butte is a very unique topological feature and is an integral piece to the rich ecosystem found in the rolling hills of